Thank you, Satya, for the introduction. My name is Santhosh Nair. I've been with Walgreens for close to now, it'll be coming 2 years now. I've been working with Manish all along with various projects, and I've worked with most of you in different locations. It's been a very pleasant and joyful ride. It's been an exciting experience, and looking at what's going to impact healthcare, how the whole 30 million people being added, and how this is going to change the whole healthcare industry. It's exciting. It's going to be another exciting ride for all of us. And so, I'll just go to the next slide. This is what I just plan to cover. What is big data? Now, you've heard a lot about it, but how do you describe this to a 5-year-old child? What is this very simplistic description without taking all the technology out? How can you describe this in the most simplistic form? So my definition is not going to be the Gartner certified definition, but let's see. Then what is the significance of big data? What are the characteristics that differentiate from traditional databases to a big data implementation? Then as an organization, how can we approach big data? What are the different facets that we need to look at in setting up a big data practice? And then from an architectural perspective, I know we have a lot of technical people here, so I'll do a little bit of a technical deep dive into understanding what we have done, some of the cases what we've done at the architecture group, and also what we have done elsewhere, and what we've seen in the industry as available solutions, and then some potential use cases. So with that, I just wanted to, before we try to understand what it is, we're going to try to describe what's the problem we're trying to solve, right? So, one perspective of the problem, let's move to the next slide. I'm sure you must have seen this error message. Keyboard not found, press F1 to continue. So, what it means is, computers by design are impulsive. They just react to an event. So when I ask somebody, in talking about this in a different context, somebody said, is this event-driven architecture? Well, that's not. Event-driven architecture has a lot more. But what it is by design is you have an action, you have an event, and it suddenly responds to that event with what it knows. It doesn't look at what are all the other facets about you or about the context, none of that. Now, you might say, this is a technical problem. This has happened in Walgreens. Without violating HIPAA, I wanted to show you a true patient history. Can you move to the next slide? This is my record. I've been a loyal Walgreens customer. I've been filling my prescriptions all along. And I always got it refilled, and I used my mobile device to scan and fill. And I had a 1-year running prescription, and when the prescription ran out to fill for the next time, they had to call the doctor for an extension, and the doctor wanted me to go and see him before he can write that's other side of the business. But anyway, they reached out to the doctor and I had to call him up. And then I got an email suddenly saying, unable to submit your to an insurance carrier, and they declined. So I called up the Walgreens store, which is next to me in the harbor, and they said, oh, your prescription is ready to pick up. So I said, oh, I got this email, what do I do with it? You can ignore this, we get all these messages. Then I said, oh, no, I work for Walgreens, so can you tell me what went wrong so that I can try to explain and tell some of the friends out there? Oh, if you can do that, please do so. We get all these emails and... So, the impulsive reaction, how computers, there is nothing, probably, I know that QA has tested it, everything is working according to the business requirements, but computers react to things impulsive. That's how it's by design. So this doesn't make sense to me. You can see I've been filling all this along, but it doesn't make sense to me. So, what makes sense? We make sense all the time. So switch to the next slide. We make sense all the time. This is a 1668 painting called Allegory of Five Senses. The little boy pointing at the mirror shows our ability to see. This child holding a flower talks about our ability to smell. This little child with an instrument shows our ability to listen. This lady holding a bird shows our ability to touch and feel. And this lady holding a fruit talks about our ability to taste. And so what do these 5 senses do? They provide us data for perception. Right? So there is a reason nose is just on top of our mouth so that you can smell it before you eat it. So if it smells awful, probably you're not going to eat it. But computers will, because they don't smell it first. So how we behave and interact to the world around us collectively, taking all the different inputs we get from the different senses, and we react. So if somebody is sad, we don't really crack a joke. Somebody is happy, we try to ask. So we see things, we talk to them, we form a perception, and we react. So computers by design don't do that. Big data is a platform, is an approach that could help us in developing computers that could make sense collectively. Now, if I say, oh, with the big data you implement and you will have thinking computers, that's not exactly the case, but this is a very simple way you can describe what's the core purpose behind big data as a platform to make sense. Okay, move to the next one. So, again, without a Gartner certified definition, we need to extract and store every available data and then analyze them in its entirety before we start an interaction or during the course of a discussion. We have to always understand holistically. The computer system needs to do that and drive some sensible action. So that is a basic definition. So how you can simply describe what's the purpose behind big data. Move to the next one. So, what is the significance? Data is the new soil. This is a term that has been heard many times. Why soil? Human being as a civilization, our civilization started with agriculture. I mean, our ability to form, group things, and then, people eating together at the dinner table, we talk. So that's how cultures were formed. This particular graph has been published in Wall Street Journal, which says 5 million years ago, humans had a common ancestor with chimpanzees. This has been proved by DNA sequencing. So by the way, it also says that all humans are originally from Africa, and then they moved out. So the modern day humans, if you look at it, this is the time modern day humans have been living on this earth, which is this is the biological anthropology people talk about it all the time. We lived on this earth for a very small period of time compared to the many other species that has lived on this earth, and we still share a common ancestor with chimpanzees 5 million years ago. Within that short period of time, how humans have transformed the world, and what are the significant fundamental difference that differentiates us from the rest of the species as humans. Dr. Jane Goodall, I don't know, you must have seen the recent movie on chimpanzee. She was the mastermind behind it. Dr. Jane Goodall spent a lifetime living with chimpanzees and understanding how we differ from the rest of the species. And he says the fundamental difference is humans have a complex language. We can communicate. So if you look at the evolution of how humans changed and transformed the world, first is the language. Second, I would call it the printing press. You have an idea, you can distribute the masses. So that is how we got freedom and independence. People thought that we should have our own self-government. How people could group, come up to a struggle, a fight, and take charge of ourselves. So we are free because of the printing press, and we have an idea, we can communicate to masses, and we can group and get things done. And when I talk about what is the significance of social media today, I used to tell folks, ask the people of Egypt. People of Egypt, so print media, other mass communications have liberated people and given them freedom. But some regimes survived. So the impact of social media in our life is so profound. To most of us, what we gained with print media and various other mass communication mechanisms, places where that didn't work, social media went and changed. That's the profound impact of driving our civilization to the next phase. To that end, I would say data, and what data is going to do next, is going to profoundly transform the way we see our life, the way our children are going to live their life, and so on. Because it's so significant, let's move to the next slide. Data is the new oil. Oil is the money. Data is the new oil, just like crude. If it is not refined, it's not useful. You have to take data, refine it, and make it usable. And data, not just small amounts of data, but very large amounts of data, to the way we react to things. Multiple sources, take all of them, and ability to process data at massive scale. So that is why I would say data is the new oil. So by 2015, the IBM prediction says there will be 8 zettabytes of data. So from a CIO perspective, from a company perspective, ability to take data into greater business insights and more profitable decision making, those companies are going to make a difference. So big data, therefore, is not an option that you can sit back by the side and see somebody else do and then wait for it to happen. So let's move to the next one. So what are the characteristics that very clearly define or differentiate big data from a traditional database or from other traditional sources of data? First is the volume. You need to have very large amounts of volume. So your social media feeds. So if you are talking about an obesity campaign, there is a study saying that if all your friends in your friends network in Facebook are obese, the likelihood of you being obese is very high. So how can we study? So how can we study all your network structures across your social media and then come up with a targeted campaign to make meaningful interactions? The server log files, you take your mobile phone, you interact, you go to a website, you see some things. So where have you been clicking in the past? When did you walk into the store? So now you have the loyalty app in the iPhone passport, and when you walk into, if you set up your home Walgreens store in the loyalty app, and you walk in with an iPhone to a Walgreens store, automatically the loyalty card will pop up. I tested it, it worked. So basically, we know when you walked into our store. We could figure that out. So using every possible data, collect all that's relevant to make sense. That's the volume. So that also drives the variety. So So you need variety of sources, structured, unstructured, semi-structured, and all other forms that you can collect. Then it's not just always about passive decision making, it's about active decision making. It's the speed at which you catch the data, the velocity, that's important. And above all, the quality. It has to be sensible. So, Facebook, how many times people feed? I'm sitting at the basement, what's the value does it have? So you have to have an ability to filter through this huge amount of data that's being generated to take what makes sense. That's very important. So those are the 4 facets of making big data as a platform a differentiator. It's not traditional rows and columns and relational database, but it is a collection of everything put together. Move to the next slide. So volume, is Walgreens big? Definitely, no doubt. I don't know, I was surprised about reading some of these facts. Walgreens was Fortune magazine's most admired company for 19 years in a row. Currently, on the web, there are 6 million visits per week. On the mobile, there is 3 million visits per week. On the social media, have reached 20 million. You all know how big our size is. But with the Boots acquisition, Walgreens is the largest pharmaceutical distributor in the world. So, all of us are at a place so great, I feel so passionate about being in here as a part of the world's largest pharmaceutical distribution. The kind of things we can use, the kind of ways in which we can leverage big data to drive our business to greater heights is unimaginable. Next slide. So Walgreens itself is big, and world as a whole is even bigger. And this is some of the predictions that's given by a research group. 4.9 million patients will use remote health by 2016. So you can read the numbers. Currently it's 500 petabytes. It's going to be 25,000 petabytes by 2020, or it could be more. That's the massive amount of explosion in data we are going to see in a very short time. I don't know how much of that 30 million new people that's going to be insured is added in here, but when the new law kicks in and when more and more people are getting covered and more people have access to medical devices, then how remote care and stuff like that we talked about earlier, how is that going to add to the whole landscape of data being collected and stored? Move to the next one. So with all that volume, how are we going to see big data as we see implemented? So there is a series of unstructured data sources. There is a series of mobile devices. So we are running Connected Health is running programs. Every other medical provider is also providing things like various kind of Western devices like the Nike pedometer and so on. They're all sending data, the sensors and all kinds of stuff that's going to send data. The various mHealth devices, the data exchange we have with HIEs and ACOs and all that stuff. All of this data is going to be sent. You have to have some kind of mechanism to figure out what's your integrated platform. And some of them might continue to stay in the relational and some of the traditional analytic cases for companies like us who would transform our time, and then parallelly we need to have the big data repository, and then from this we need to find ways to present data, analyze and present data. That's how this whole system will come about. Next one. So this is therefore an approach to how we can, what are the kind of different functional groups we need to have in our organization, probably to have big data realized. So first is obviously we talked about innovation a lot. You need to have ideas. It doesn't necessarily have to be, we have to have all the ideas, but it's a continuous ongoing process. From a data perspective, we have to collect, extract and collect every available data source. Then we need to filter them. So as I said, people are going to have all kinds of posts on Facebook. Most of them are not relevant for us. Some of them are relevant. So we have to look at what we need, learn to understand what we need. That itself is a big process. Then obviously we have store, and how do we store and analyze? There are a lot of solutions which I will cover. And then we have to find ways in which we can present this meaningfully. That can make sense and that could drive sensible actions. So if potentially you would see, we would set up groups that focused on each of these areas maybe. Leave it up to us how we can plan this, but that's an approach. Move to the next one. So with that, I will take a little bit of a deeper dive into some of the technical facets of big data. Next. So high performance computing has been around for a long time. I don't know whether anybody of you remember, we used to contribute some amount of our CPU time on the internet so that somebody can run some process on it. And collectively we could build a large high-performance computing system. That used to be the case. So when you talk about large amounts of data, big compute over small data is different from big compute over large data. There is a fundamental difference. And Google was the first to hit this problem. Google or other internet search engines were the first to hit this problem. So if you run any job, you might know the bottleneck is always the disk. It's probably not the CPU. How many CPU cycles you can crank is probably not where things get held up, because one hard disk can read 75 megabits per second. So if you can put 1,000 hard disks and all of them parallelly read, then you are talking about 75 gigabits per second of processing capacity, and that is what we need to drive the amount of data we're talking about. So next slide. So Google, as I said, was the first to hit this problem. Well, probably not the first, but one of the first to come up with an innovative approach to solve this that took market by storm. And this is a white paper which you can get. I'm sure you're going to get the slides later. The link is down here. This is a very interesting white paper. It's not complicated like a research paper. It's very easy to read and figure out. Google invented MapReduce. They patented it, but they opened it up. Now it's not restricted by anyone to use. And created a programming model where you can map a large and complex request into a set of intermediary tasks, and then you can collect those intermediary results and perform another function called reduce to reduce them to your final output. So this is one programming model which Google created. Next. I wanted to also touch upon a subject called fabric architecture. People who have been in Health Cloud, you must have heard App Fabric. Microsoft is talking about App Fabric as the development platform, the way how they develop things. So what is the reason for the term fabric architecture? So when you put so many computers all connected up through some kind of network, and you zoom out and you look at it, this looks like a piece of fabric. It's all connected, right? So that is fabric architecture. So there are high-performance computing, various other big data platforms, cloud computing, they all make use of fabric as a concept. But with this, what Google did is Google created Google file system, which now is available in Hadoop called HDFS, or Hadoop file system. So what it is you throw a file, it spreads across multiple servers in the node, but it appears to you as one file. Driving that 1,000 hard disk reading at the same time to get the speed you want. So you can skip to the next one. So I want to introduce some of the core technology concepts. Again, we mentioned about Hadoop. Hadoop is an open source implementation by Apache that implements two things: MapReduce as a framework, and the Google file system in Hadoop called the Hadoop file system. That drives high performance parallel computing. So you can go to, again, Apache Hadoop, Apache website, and it's downloaded for free. Go to the next one. So what Hadoop consists of, as I mentioned, is the MapReduce layer and the HDFS layer. So the reason why I talked about fabric is it's important to know that in the fabric you have a fabric controller. The concept of a controller is relevant in big data as well. So there is a controller that controls and distributes the work. So there is a job tracker, you submit a job, that's the MapReduce job. It splits them into all the nodes, reduce them, and again assigns the reduce function to all the nodes and get it done. And HDFS distributes the file that you're working on to all the computers across the node. Go to the next one. So a little bit deeper into HDFS. So in the Hadoop file system, what you have is a name node. And the name node, so you just refer to a file like this, right? Typically. And the file is actually living as pieces in several different computers across the node. And typically, a default of 3, which means it takes one piece of a file and copy it 3 times into 3 different computers. So, if one fails, it knows the data where it is available next, and it will assign the job to that node. So it therefore gives you true linear capability. So what that means is you have a rack of servers, remember fabric in the node and structure type. So one goes away, nothing happens. You can put another server and configure the cluster controller and say that, oh, I have a new server. Suddenly the controller figures out and starts giving him data. And once you have data, it starts giving him jobs. You can take away or add while the system is in production. Next slide. So, how a typical MapReduce works in an implementation? So as I said, there is a master job tracker. It's important to know that there are a couple of facets to it, right? This is rack aware. Rack aware means when you have a stack of nodes in one rack and you have multiple series of racks, it will assign a job with who holds the data. So when I know that the HDFS file system has distributed the file to how much ever computers nodes you have, a map function will go to that computer that holds the data. Always a node will get a job to do where the node has the data available locally. And then, so it's right aware, because if there's a node that has nothing to do, then you might get a task to perform where you have to get data from somebody else, but which is very unlikely. So it knows the structure and the topology of the network so that it knows how to assign the map and reduce functions to which node so that you can get the fastest possible performance. And so first is the map process that maps to intermediate results, and then it's the reduce process that reduces the intermediate results to your final result. The next slide. This is an example of a map reduce code. I don't want to go deep into it. I think I'm already running out of time. So this is the classic example of Google. So they need to quickly count how many times a word repeats, and that way they rank the words, they rank the document by that word. So this is an example. So you simply say map string value, and then you get set of intermediate results, and then get to the next one, which is the reduce function that gives you how many word count. You skip to the next one. So this, after doing this, we did an experiment in pharmacy. Architecture, a group. We created, this is after the RSP project. So we kind of took Hadoop, installed it in our notebooks and played with it. And this was an example of giving a typical flat file data. We threw it into Hadoop, we created a string, we created a sort of intermediate results. You can move to the next one. And then we did the reduce function to get the final results. So again, the slides are there. We can take the details if anybody's interested later during sessions, either architecture back in the office or here. You can skip to the next one. So then now I want to talk a little bit about what are all the tool sets you have. So after Google initiated the creation of Hadoop and stuff like that with open source it, Facebook created Hive, which is an SQL-like interface. So, writing all the map and reduce and all that stuff was complicated, right? So you still use two SQLs, so you can write an SQL and use an underlying big data platform, and to do that, you have HiveQL, which is very similar to SQL. Next one. So then there's a company called Cloudera. Cloudera created Hue, or Hadoop User Experience, and by the way, the founder of Cloudera was ranked the world's smartest engineer by CNN Money and Forbes and so on. They created a graphical user interface. Some people might say that takes the fun away. But for those who don't want that fun of going through code, you have a user interface available on Hadoop. Go to the next one. So simply running the HiveQL, you can get the same kind of results what you've seen in the earlier case. Next. And Cloudera's distribution so Cloudera has taken Apache Hadoop and various other things they have wrote, and they also have their own manager, and they have created a distribution called Cloudera's distribution of Hadoop, or CDH, and the current version is 4.1.1. You can go to Cloudera, and it's a free download, and these are all the things that's packaged into that Cloudera distribution, which includes Apache Mahout, which is a machine learning library. It includes various, workflow coordination for Uzi. Pig is by Yahoo, started by Yahoo, but it's to do analytics. And then Scoop is to scoop basically from SQL to Hadoop. And Zookeeper and so on. So all these are packaged as a single distribution by Cloudera's distribution. So that's very easy. You can move to the next one. So you can do it yourself. And we can help. So this is a Hadoop distribution in a basement. So that's the cluster controller, and these are the two racks. That's it. There you go. Next one. So quickly, I will run through some of the use cases. I know that we are getting close to lunchtime. Some use cases. Next. This is Hippocrates, 460 before Christ. He said, disease is not because of an act of God. And he went into jail 20 years for saying that. And he wrote a book there. We still call it evidence-based medicine. We are still far from it. How much of data we are collecting and analyzing and giving a treatment to somebody based on true evidence data. It's still far from it. He is regarded as the father of medicine, but evidence-based medicine is still far from reality.